Hello guys, in this video we are going to learn the important topic that is nothing but speed torque convention for multi-quadrant operation. In this video we will be discussing about the multi-quadrant operation as well as the hoist load, how to consider the hoist load and understand the concept of that hoist load. Okay, so here we have the multi-quadrant operation of drives. So this is the drive operation. We have four quadrants. This is the first quadrant where we have forward motoring. Okay, forward motoring. Second quadrant we have forward braking. Third quadrant we have reverse motoring, and fourth quadrant we have reverse braking. Now how this all things have come? Simple thing, here we can see the x-axis is torque and y-axis is nothing but the speed. Okay, it is the speed. Now speed and torque, you remember this thing. Now first point I have taken here, motor operates in two modes of operation, that is nothing but motoring and braking. Here you might have seen braking and motoring, only two kind of things is there. Okay, so motoring and braking. In motoring what happens? Motoring basically what happens, it basically converts the electrical energy into mechanical energy which supports in motion. As you know, motoring means what? Electrical to mechanical. Braking what happens? The ulta case, that the reverse of this. That means it works as generator in braking and converts the mechanical energy to electrical energy and therefore opposes the motion. Okay, supports the motion. Why? Because it is rotating in the same direction. Why? That's why it is supporting. Now in braking what happens? It will oppose the motion because it will work in opposite direction. That we'll understand when we'll take up the hoist load and all. Okay, so for this case you remember two modes of operation, braking and motoring. Now motor can provide motoring and braking operation for both forward and reverse direction. Now this direction, most important thing. Now you understood that for motoring and braking is there. Now why we have to take in first quadrant forward motoring, second quadrant forward braking, that we'll understand in a simple way. Listen carefully, this is an important point. Now forward direction and reverse direction, F and R. Now this is basically based on the sign of speed. Sign of speed. That means forward will be positive sign speed. Okay, and reverse will be negative sign speed. That means in quadrant you might have studied in Cartesian plane, you know which side is positive, which side is negative. So this axis, this side it is positive. Let us not see that. Why? Because we are considering only speed. Speed is in which axis? Y axis only. So you have to consider this line only. This line, you know, this is 0. Above this line, this part, it will be positive, right? Positive speed. Below this will be negative speed. Okay, so as you can see, above this 0, it is positive speed. So we have two cases of forward. See, simple. Speed, as I said, this thing you remember. Forward basically means speed will be positive. Simple. Reverse means speed will be negative. So below this you see, here we have two cases of reverse. Why? Because in Cartesian plane, if you remember, below this 0 we have negative numbers, right? That's why I said it is negative. Only you have to see y-axis. Only you have to see y-axis, not this torque one. Okay, so this is how we got forward and reverse. Remember, forward means positive speed, reverse means negative speed. Simple. Now what about motoring and braking? How this came? Simple thing. Let me just erase this part. Now for motoring and braking, what you have to do, here I have considered one important point. This point you see, power developed by a motor is given by a product of speed and torque. That means motoring will be positive power. So let me just write it over here. Motoring will be what? Positive power. How we can get positive power? Positive power we can get when you multiply. See, they have said it is a product of speed and torque, right? So in this axis you see, in first quadrant you see, torque is here. Torque is what? Positive or negative? Here as we know it is positive numbers only, correct? And speed anyways it is positive only, this direction. In first quadrant it is plus plus. You might have studied, right? Plus plus. So product of plus plus, product of speed and torque, it is plus into plus is nothing but plus only. That means it is positive power. I hope you got it. In first quadrant, I am talking about only first quadrant. In first quadrant, power is nothing but the product of multiplication of the speed and torque. You have to just sign, you have to multiply. Here both the speed and torque is what? Positive, as you might have studied in the max also. Yes, Cartesian plane. So here you have to consider, here we are getting positive power, that is nothing but motoring mode. Okay, now let us go for second quadrant. Second quadrant we have braking. How we got braking? See, again this axis is there, this part is there. So let me just take, okay, this part and this part, right? This part, this is the second quadrant part. In this part, the torque here it is negative, right? This part is negative. Then here it is anyways positive speed. So speed is positive, torque is negative. Here we have speed into torque, it is nothing but negative into positive or positive into negative. We'll get it as negative side. You have to multiply. Okay, so plus minus we have got in second quadrant, so you are getting negative side. Negative sign, what you're getting? That is nothing but negative power you're getting, right? So power in second quadrant is negative, so by we are telling it as it is the mode of braking operation. Okay, now if we come again third quadrant, if you see here we have got motoring mode. How we got motoring mode? Because power is positive, positive power. In braking mode, always remember power will be negative, negative power. How we are getting negative power? Because it is the product of speed and torque. If speed and torque product is negative, then it is negative power. Okay, so in third quadrant, let us just quickly see what is happening. So this axis is there and this axis anyway is negative, this axis also negative. Negative into negative is what? Positive, correct? So positive power we are getting. Here if you see fourth quadrant, here we have positive x-axis and negative y-axis. So negative into positive, it is negative, so negative power we are getting, that's why it is braking. So this is how you have to remember. So in multi-quadrant operation of drives, two things you have to remember. Motor can operate in two modes, motoring and braking. That too in forward and reverse direction it can act. So reverse and forward direction depends upon the speed, whether it is positive, only on speed, whether it is positive or negative. And motoring and braking depends upon the power, whether it is positive or negative power. Power is nothing but the product of speed and torque. Just thing you remember. Okay, let us go for a hoist load. This is most important thing in terms of examination point of view. Hoist load. So let me just explain what is this hoist load. So they will be asking you 4 quadrant operation of a motor driving a hoist load. This is most important question they are asking. Okay, so here also we have 4 quadrants. So let me just go for the hoist load. What it means, hoist load is nothing but this part, whatever they are talking about. So here a hoist load consists of what? A rope. Now this is nothing but the rope. Here we have rope. It is wound around a shaft or a drum which is coupled to the, see, one drum is there which is coupled to the motor shaft. Okay, and here we have rope, one rope we have which is coupled to the motor shaft. Motor will be there in order to run this. No, we need motor. So one end of the motor is connected to, or it is tied to the cage. So here we are tying the cage. This end, here you can see in diagram, this end we are tying it to a cage. Now this cage can be empty or loaded. It can be loaded cage or empty cage, two possibilities. Okay, and other end of the rope we are connecting it to a counterweight. Here you can see all the diagrams is the same thing, only difference is that empty cage or loaded cage will come. Now here we have one end of the rope, we have counterweight. Okay, counterweight. Now this cage, why we are using cage? Cage is nothing but to transport one material or man or person or working man, labor or someone to one level to the other level we are transporting. Okay, it can be upward direction or downward direction, any direction it is possible, considering the fact that we are taking loaded cage or empty cage. Okay, so upward direction or lower direction is possible. Suppose you consider construction workers, they have to go from one floor to another floor. This is first floor, this is second floor, so they have to lift upward direction, they have to reach second floor, or they have to come back to first floor. Anyways, upward direction or lower downward direction, both things should be possible. Okay, so it is nothing but counterweight is there. So counterweight, now this weight of the counter is basically taken. How we have to choose the counterweight? Counterweight should be chosen such that it should be higher than the weight of empty gauge. Suppose empty gauge is what, 10 kg. Sorry, empty gauge, let me consider 0 kg. Okay, no, just assumption. I am not telling that it is a fact empty gauge will be 0. No, I am just assuming. Empty means, for example, it is 0. Now counterweight should be higher than empty gauge. So if you compare counterweight and empty gauge, that means counterweight should be higher. So let me consider this is 100 kg, this is 0 kg. Okay, simple thing. Now next point is that loaded cage is also there. So counterweight should be less than loaded cage. That means if I consider counterweight, I have considered 100 kg, so loaded cage should be greater, right? So I will consider 120 kg. So this is the scenario. Okay, so here we have empty cage 0, counterweight 100, and loaded cage is what, 120 kg. This is just assumption I am giving so that you can get some kind of idea about the weight of the cage as well as the counterweight why we are taking. Okay, so this is about the hoist load. Hoist load is nothing but it consists of a rope wound on a drum which is coupled to the motor shaft. So two ends are there. One end of the rope is connected to loaded cage or empty cage, other connected to the counterweight. Counterweight, you have to compare the weight with the loaded cage as well as empty cage. Loaded cage weight should be greater than counterweight, and empty cage weight should be less than counterweight. Simple. This much concept if you understood. Let us go forward. Before that, if you observe here, we have one line, right? One vertical line we have, it is TL1, and here also we have one vertical line, it is TL2. What is the meaning of these two lines? Now TL1 is basically what, a low torque. Okay, this is for first quadrant and fourth quadrant. As you see, this line is passing through first quadrant and fourth quadrant, so that's why I said it is the low torque for the first and fourth quadrant. And this torque is nothing but the difference of torque due to loaded cage and counterweight. This is important. Okay, simple. It is quite simple. If you see in the picture also, low torque with loaded cage. That means in these two quadrants, first and fourth quadrant, if you see, they have considered loaded cage. Correct? Loaded cage, one end is loaded cage and other end is counterweight. So it is nothing but the torque. Load TL1 is nothing but the torque which is associated with the first quadrant and fourth quadrant, and it is nothing but the difference of the torque due to loaded cage and counterweight. Now what about TL2? Simple. It is also a load torque, but it is associated with the second quadrant and third quadrant. If you see, this TL2 is passing through second and third quadrant, and it is also the difference of the torque due to what? Due to empty cage, and counterweight. Simple. Counterweight. All these notes will be given in the description. You can just go through that. Okay, I'm just explaining the part, so when you see the notes, you will have a clear idea, okay, about what is happening in these quadrants. Now here I have explained about TL1 and TL2. Okay, this much you remember. Let us go for the next thing. So as you see here, we have taken motion. Correct? If you see, observe here, in each quadrant they are having motion. Now motion is considered to be in upward direction, so that motion is considered to be forward. So if you see, why I am considering this as forward motion, upward motion, why? Because in first quadrant you have studied, it is nothing but forward motoring, correct? So forward is there, that's why upward motion. So let me just write it over here. Upward motion basically means forward direction. So what will be second quadrant? Second quadrant is forward braking. Don't see braking, I'm just talking about forward direction. That's why it is upward. Now these two quadrants, if you see, it is downward. Why it is downward? Because this is reverse motoring and this is reverse braking. So reverse means it is downward direction. So downward direction because it is reverse. Okay, this much you remember. So we have talked about motion, why we are considering upward and downward. That's all. Let us go for each quadrant, what is happening. So here we have the first quadrant. Let us start with first quadrant. Okay, this is the first quadrant. So in this quadrant, what is happening? Motion is upward because it is forward motoring. Okay, forward direction is there. Now if you observe, here we have three signs: omega m, TL and T. T is nothing but the torque, TL is the load torque, and omega m is the speed of the whatever the motor is there. Okay, so we have to, here remember, here we have loaded cage and counterweight. As I said before, that loaded cage weight will be more than counterweight. Okay, so loaded cage, let me consider 120 kg is there. This is all assumptions. Okay, here let me consider counterweight is 100 kg, or you can take 150 also, anything is fine. Now due to the fact that the heavier object, anyways, you might have seen seesaw, right? If one person sits over here, if it's a 200 kg person, here it is 100 kg person, of course it will come down. 200 kg person will come down, right? The same scenario is happening here. So because of the natural gravitational force, the loaded cage will be pulled downwards, right? It will come down naturally because it is having more weight than counterweight. Naturally it will come down. But what we want the motion. You observe the motion direction. We want motion to be in upward direction. We want to pull this cage in upward direction. Now in order to pull this cage in upward direction, what you will do? You have to apply some torque. Which direction you will apply? This direction you will apply, right? So you are applying this direction torque. What about this omega m? Omega m is nothing but the speed. That you can write directly in all the quadrants without saying also, because omega m is nothing but the direction. So this direction you can see motion is upward, correct? So it is moving in anti-clockwise. See, here also motion is upward, so it is moving like this, anti-clockwise. Here motion is downward, so you have to move clockwise. Motion is downward, move clockwise. So omega m, you can write it in all the quadrants. Okay, it is based on the motion, or you can consider forward and reverse. That's it. Now here let me just quickly explain you what is happening. Motion should be upward direction. This is the motion. Okay, this you remember, this is important. But loaded cage, what will happen? It will pull down. But what I want to pull up to some certain distance, right? So I need motor to work in this direction, right? I have to pull, right? So I have to work in this direction. So that's why torque is in this direction. If you observe, torque is in that direction. Speed, I'm not talking about speed again and again. As I said before, speed will be in this direction only, because the motion, if you see, it is in upward direction. You have to upward direction basically means you have to go like this, anti-clockwise. That's why it is omega m is like that side. Okay, motion, or you can consider the forward direction. Okay, now what is TL? TL, always remember, it will be opposite of this torque. That means it will be opposite of this thing, TL. If T is anti-clockwise, TL will be clockwise. That's it. This thing you remember. So this we have finished with the first quadrant. Let us go for second quadrant. In second quadrant, as I said, speed already we have discussed, the motion direction. Once again, let me just draw this one. Now the difference here is we are having empty cage. Okay, we are having what? Empty cage. So whenever here empty cage is said, let me consider 0 kg and this is 100 kg counterweight. Now naturally, which will come up? This will pull down, right? So this will go up, cage will go up. Since it is empty, it will go up, and counterweight will come down. but what I want, it is naturally it is happening. See, motion is also in this direction only, so I want motion also in this direction, so it is naturally happening. So what is the use of motor then? Here it was not naturally happening. Remember, in first quadrant it was not naturally happening because loaded cage was pulling down. I wanted it to go up, right? That's why I use motor. Now here anyways it is going up, motion is also in forward is going up, then what's the use of motor? See, it is naturally going up, so I need some braking mechanism, right? So in order to stop, in order to limit the speed of the empty cage, I need what? Braking mechanism. That's why I'll apply the motor to run in opposite direction. Torque will be applied in opposite direction. Why am I applying it in opposite direction? Because I have to resist the flow or resist the speed to some certain limit. That's why. Okay, so torque will be acting opposite direction. What about TL? TL will be acting opposite of this direction. So here you can see, observe this pattern. Torque is clockwise, TL is anti-clockwise, speed anyways we discussed, it is anti-clockwise only. Okay, so this is what's happening in second quadrant. Let us go for the third quadrant. Third quadrant, what is happening? Speed anyways we have discussed. This third quadrant is nothing but reverse motoring. Okay, this is empty cage, so let me draw again. This is empty cage, this is counterweight. I want motion to be in downward direction. Okay, but what empty cage will do? Empty cage anyways it is empty, this is 0 kg and counterweight is 100 kg, so counterweight will pull down, so this empty cage will go up. This is kind of a well, imagine well, you draw water from the well, right? So the same thing is happening. You're standing here, you're pulling down, this counterweight is you're pulling down, so this empty cage, you consider this as the that well thing, or water container, that thing. Okay, that drum kind of thing that you're pulling up. So but what I want, motion to be in downward direction. I want, this is important, motion I want downward direction, but naturally it is going upward direction, this cage. So I want to bring it down. So what should I do? I should apply the torque again in the clockwise direction, right? I have to apply the torque in this direction so that motor will rotate in this direction and it will bring down the cage. I need cage to be in downward direction. That is the main objective. See, on all the cases the objective is nothing but you have to see the motion with respect to the cage, where I want, upward or downward. Based on that you have to do. This is again motoring because it is same direction, you have to pull it down. So torque is applied in clockwise. Anti-clockwise will be TL. So same thing it is written over here. Next, fourth quadrant, what is happening? Speed anyways we have discussed. So one loaded cage, again loaded cage came. Okay, this is counterweight. So loaded cage is 120 kg, this is 100 kg. So naturally what will happen? Naturally this will pull down, this will go up. Yes, but I want motion to be in downward direction. So anyways it is naturally going down only, right? Cage is going down only naturally. See, motion is also downward, naturally the cage is also going downward. So what's the use of using motor then? See, I have to limit the speed of the motor. Now speed of the motor means I have to limit the speed of this cage. So for that I will be using motor, that too in reverse direction I have to use. That is, torque will be acting in opposite direction of this cage is going downward. I have to resist the motion. I cannot make motor to run in this direction only, right? Because anyways it will support the motion of the cage itself. So I need to run it in opposite direction. That's why torque will be in opposite direction, and TL also will be in opposite direction of torque, that is clockwise. Okay, so this is what is happening here. Okay, the simple thing logically you have to understand. Now I will tell you one trick to remember this direction of torque. Now coming to the trick part, simple. This first quadrant is forward motoring, second quadrant is forward braking, third quadrant reverse motoring, fourth quadrant reverse braking. This much you write first. Now remember, for motoring, important point, this is the trick. For motoring, the direction of omega m and torque will be same direction. So speed anyways you know how to write. How will you write speed? See, motion is in upward direction. That means it has to rotate this way. Correct. It is going like this and rotating like this. So it is anti-clockwise. Or you can remember like this, upward means, upward motion means it is anti-clockwise. Okay, speed I am talking about speed. So let me just once again write. So speed I am taking anti-clockwise. Done. Motion, if you see, it is upward, so speed again anti-clockwise. I am taking speed anti-clockwise. Motion is downward, right? So I have to take motion clockwise. Not motion, sorry, speed clockwise. So omega m clockwise. Here also motion is downward, so speed again clockwise. So speed is done. Now simple trick is that for motoring we are having speed and torque in same direction. So that means this case is motoring case, and one more case is there motoring. This also motoring case. The first quadrant and the third quadrant, it is motoring case. That means in that, if the speed is anti-clockwise direction, the torque also will be in anti-clockwise direction. Simple. Now if torque is in anti-clockwise, as I said before, the opposite direction will be the load torque. That means it will act in opposite direction always. So this thing we have got directly. Simple. Now coming to this part also, third quadrant, here also it's the same thing. Now speed, you see, speed is in anti-clockwise, so it is motoring case. So again it will be in same direction, torque will be acting, and low torque will be in reverse direction, opposite direction of torque. This is what happening in third quadrant. Let us go for the second and fourth quadrant. Now in second quadrant, if you see, speed second quadrant is here, speed is anti-clockwise. So whenever braking is there, braking mechanism, there omega m and torque will be in opposite direction. That's why I said make the sign or the clockwise or anti-clockwise, specify it first. Speed you have to specify it first, okay, then only you can make this torque direction. So speed anyway, second quadrant, if you see, it is anti-clockwise. So this, since it is braking mechanism here, I have to apply the opposite torque here. Torque will be in opposite direction. So what about TL? TL will be opposite direction of torque, so that will be anti-clockwise. Coming to third quadrant, fourth quadrant, speed is in clockwise. This is braking mechanism, so it should be anti-clockwise. Torque should be anti-clockwise. TL should be opposite of torque, that is clockwise. So I hope you understood. Only this part you have to remember: motoring, braking. Simple. Okay, so this is how you have to remember the signs of each case. Okay.